Okay. I'm going to get started. First, I'll be up front. I am terrified that I'm not going to be able to do this in an hour. So I do apologize. I am going to be glancing at my phone to see how I'm going on time. Or maybe, Mark, can you just flag me every 15 minutes? Every 15 minutes, stand up and be like.
I'd be happy to do that.
So before I get going, hello, I'm Ben Armstrong, Program Manager on the Hyper-V team, well known as the blogger Virtual PC guy. Here today, I'm hoping to do a very quick run-through of how to get the best performance out of Hyper-V. But before I do that, I always like to ask some questions of my audience. So first, how many people here are using Hyper-V 2012 R2 in their environment today? Fantastic. How many people have 2012? Okay, 2008 R2. Okay, glad to see small hands. My first tip to you guys is get to 2012 R2, everything else doesn't matter. There's huge performance improvements. If you care about performance, that's your first step. So a couple of other questions. How many people here are doing converged networking in their environments? Okay, that's kind of low. I'm not surprised, but that's kind of low. So I'm going to be talking a bit in the networking section. I'm not going to be touching on converged networking, but I would really encourage people to be looking at that if you care about performance. So how many people here are using SANs in their environment for storage? Okay. Now, how many people have at least looked at the ScaleUp file server technology for storage in their environment? Fantastic. Do we have, and finally, do we have people using ScaleUp file server in production in their environment? Got a couple of hands. That's, once again, kind of what I was expecting. I'll be talking about that as I go along. So, with all of that, let's get started. First one, obvious question, kind of. Why should you care about performance? This is actually important because we get a lot of people coming and talking to us about performance for the wrong reason at the wrong time. So I want to talk about why should you care about performance and when should you not care about performance. So first, getting the most out of your hardware. It amazes me. I've done a lot of work with different customers, and when I first start working with a customer talking about performance, and they tell me the specs of their hardware. Oh, you know, here's what we've got network, here's what we've got storage, here's how things are put together. And we start performance profiling. Usually, they are getting somewhere between 50 to 30% of what they thought they were getting out of their hardware. And that's a huge waste, you know, just because they haven't gone through and tuned the system and understood their system. So getting the most out of your hardware. Choosing new hardware. You know, hopefully you guys don't believe what vendors tell you, you don't believe what Microsoft tells you, you actually go out and try it out. And you know, when you're looking at new hardware, you should be trying it out, you should be testing the performance and measuring it. Delivering great customer service. So when we look at cloud environments and when we look at the subject of performance, let me tell you the two most common mistakes that I see that once you're here, there's no such thing as good customer service. The first one is failing to set an SLA up front. You know, and you would be amazed the amount of people I see doing this, because let me tell you, if you do not have an explicit conversation with the people who are using your virtualization infrastructure about what performance they can expect, then you are setting an SLA and it is infinite. You know, they will always have the ability to come back and say this isn't fast enough. You know, it is important to set those expectations up front. The second thing, though, is too often the way we know that we have failed to deliver the performance our customers need is because they're on the phone yelling to us. And that's the wrong way to do things. We should be measuring and understanding, and we should be aware of the problems first. Because, hey, we're the people running Hyper-V. The final thing is earning your keep in the organization. If you want to explain the value that you bring to your company, being able to demonstrate that, hey, because of me, we didn't have to buy new hardware, we're able to get more value out of it. Because of me, we have happy customers, is a great story to say as a Hyper-V administrator. So what is the wrong time to go deep on performance? And there are really two things that I want to point out here. The first one is choosing a virtualization platform. All too often, I see people going like, we're going to try and choose a virtualization platform, and we're going to do performance cook-off. Let me tell you a couple of things. The first thing is, I'll be completely honest, the performance difference between Hyper-V and VMware today is really in the point percentages. It is really small. Both of our platforms are consistently operating within 5% of native performance. It has been a very long time since I've seen someone come away with a conclusive like, oh, this workload runs a lot better on virtualization platform A or virtualization platform B. But the other thing is, if you try and do this, what you're really measuring is not the performance of the virtualization, but the capability of the people running the testing. And we have seen different organizations do the same testing, come away with different results, because the people had different skill sets. So this is rarely an informative thing. The second thing is, when a customer is complaining, is not the time to decide that you should go deep on performance. The analogy that I like to use here is, when your car is broken on the side of the road is not the time to decide that you need to learn how fuel injection works. That's a bad scene, and you're going to do the wrong thing. Make sure these are separate. Do your performance analysis ahead of time, and be ready for that moment when it comes. So, how do you start? Well, the most important thing is you need to measure where you're at. And this is really key. The number of people out there who haven't measured what their infrastructure is actually capable of and aren't actively measuring what's happening in their infrastructure. And time and time again, I see people go like, hey, we've got like dual 10 gigabit network adapters in our environment, and that's the backbone. And I get to go on site, and I'm like, hey, let's do some testing. And we find out that they're getting 3 gigabit of throughput. And it's like, well, if you want to know why you're not seeing the performance you want, right there. When you actually sit down and test and measure, quite often you'll be surprised at what's happening. So what do you measure? This is I'm about to give kind of one of those obvious answers, but so many people get this wrong. What you measure is the workloads you care about. We run clouds for a reason. And we know like, okay, I've got SQL, I've got Exchange, I've got so on. The important thing is like measure how those workloads run. Measure what you expect your customers to be doing. That should be your bar that you go after. And fortunately, if you choose your application workload of choice, there are a lot of great application level measuring tools and benchmarks. And those are repeatedly the most reliable thing to go for. Avoid micro benchmarks. And as we're going to go through this, I'm going to talk about cases where we've seen people micro-benchmarking, and it's a really bad idea. Micro-benchmarks are when you go like, well, there's this one performance counter, and we're going to tune for that, or we're going to have this little program that does this special thing. Repeatedly, I have seen both customers and I've seen engineers inside Microsoft take a micro benchmark and be like, yeah, we tuned this, and now this specific thing is twice as fast. And it's like, so how does that affect SQL? And we go and test SQL, and it's like, well, guess what? Like, the effect is so small that we don't even notice it. You know, or congratulations, you made our SQL deployment 1% faster. Micro benchmarks are a real trap. However, doing subsystem-specific tests can be useful for troubleshooting. Now, this is the key thing. Like, you should start, you know, if you care about SQL, start with a SQL test. If you care about Exchange, start with an Exchange test. If you're running VDI, run a VDI simulator. Like, run at that level. Now, if you are not seeing the performance you want, then you can start doing, like, storage-specific tests or network-specific tests to kind of do the troubleshooting. But that is the troubleshooting diagnosis. That's not what tells you if you're good. You know, you really have to make sure you're testing the workloads that you care about. The next thing on measuring is be careful about how you measure. Virtualization throws a real spanner in the works into accurate measuring of performance. And the reason why is inside of a virtual machine, we actually mess with a lot of the fundamentals of a computer system that people don't expect. You know, time is not entirely reliable inside of a virtual machine. And that affects measuring performance. So the first thing is measure from outside the virtual machine if possible. You know, you can run a workload, you can run a SQL server inside a virtual machine and measure, you know, the performance that you see from outside. That's always going to be reliable. For Hyper-V, we actually have a bunch of performance counters that we expose from Hyper-V itself about the virtual machines. Those are always reliable. You know, if you are going to measure inside the virtual machine, as a general rule of thumb, look at throughput counters. You know, look at megabytes per second and that sort of things. Really avoid percentages, because those are all wrong. And also avoid looking at queue lengths. In virtual machines, we tend to have some really weird effects on queue length counters. We either reduce them to 0, because we have a queue outside of the virtual machine and we just pop everything out of the guest queue and throw it into the host queue, and the guest always sees that it's empty. Or we stop them from ever getting to 0. And my favorite example of this is, a lot of old school performance tuning guidance said, look at the CPU process queue, and if it's routinely above 0, you've got a problem. Well, here's a hint. If we have a virtual machine where the CPU process queue is 0, we don't schedule it because it hasn't got any work to do. So in a virtualization system, the CPU process queue is always above 0. So let me just show you with a couple of virtual machines why you have to be careful about this. So I've got 2 virtual machines here. I've got Task Manager, and they're mostly idle. So I'm going to go to this virtual machine, and actually I have the performance counters in the host as well. So we're going to compare what the virtual machine sees to what the host sees. So I'm going to go to my first virtual machine, and I'm going to just kick off a little script that burns all the CPU. So it's now redlining, it's at 100%. Task Manager saying it's at 100%. And you'll see it's saying, I've got 2.7 gig, I'm using 100%, great. And if I go over to the host counters, you can see it's largely saying the same thing. My red ones are my virtual processors from my first virtual machine, and it's saying, look, yep, they're pretty much redlining. Now, where things get different, though, is if I come over to this virtual machine and kick off the same workload. So the first virtual machine doesn't believe anything has changed. It still believes I have a 2.7 gig processor and I'm using 100% of it. The second virtual machine also believes I have a 2.7 gig processor and I'm using 100% of it. And if we go into the host, what we see is, yeah, you're each getting 50%. And so this counter is useless. If I look at this inside of a virtual machine, it means nothing, because what it really is saying is that the virtual machine is using 100% of the processing time that the hypervisor is giving to it, which from inside the virtual machine is unknown. So that's a useless counter to look at. On the flip side, and that's an example of, well, you don't want to look at percentage-based counters inside of virtual machines. If I go to a throughput-based counter, though, we'll see that it's a much better representation. So get rid of that. And I'm going to kick off an I/O workload in this virtual machine. So here we have this virtual machine. It believes it's using about 10,000, 11,000 IOPS a second. This is a throughput-based counter. So now if I go and look at this counter in the host, we can see, yep, we think that we're using about that much. So it's saying 10,000 to 11,000. These are fairly accurate. If I go over to my other virtual machine and kick off a similar workload, let's bring this both up on the screen. What we're going to see is that this workload's going to come up. There's going to be contention for resource, and it's going to balance out. And they'll each get about 5,000 to 6,000 IOPS. And if I go and look at the host, you can see, like, yes, that's actually what they're getting. So throughput counters do work inside of virtual machines. But queue length, percentage-based, those are quite dangerous, so be careful about that. So let's jump back. So what do you look for when you're measuring performance? The big four is the answer. There are 4 areas where we spend a lot of time looking at. And they are, in order, storage, network, memory, and CPU. So I'm now going to step through each of these 4. And in each of these 4, what I'm going to try and do in a very quick way is step you through, and this is the process that I would recommend you apply. The process is, first you measure to understand where you're at. Second, look at what you can do to increase the available capacity of that resource. And third, look at what you can do to control it and ensure that it is distributed evenly, fairly, appropriately in your infrastructure. So storage. I want to be crystal clear here. Storage throughput is the #1 cause of poor performance in cloud environments today. Bar none. Simple. The #1 thing that causes customer calls, that causes people to not be able to run more virtual machines, that causes the mysterious, why are things running slow, is storage throughput. And one of the biggest challenges that we face is that as an industry, a lot of us aren't used to thinking about this. A lot of people aren't used to thinking about what sort of I/O per second IOPS does this workload need, does that workload need. A great example here is I've spent a lot of time consulting with people who are embarking on VDI projects and are trying to size their environments. And one of the questions that I ask them is, so most of your desktop computers have a single SATA 2 spinning disk in them, right? So not SSD, just old school. And they're like, yeah. I'm like, do you know what sort of IOPS that can deliver to your user today? Most people don't know the answer to that. If you're curious, depending on the manufacturer, it's about 70 to 120 IOPS. But if you don't know that, how can you account for that in a larger system? How can you know what's reasonable and unreasonable? So the first big thing here is just getting used to thinking about storage throughput and measuring it and talking about it. So increasing storage performance. Let's say you've had your deployment, you've done an application benchmark, you've tested SQL, Exchange, VDI, whatever. You've seen that, okay, this isn't where I want it to be. you've gone through and you've done some subsystem checking, and you're like, oh, storage. Like, my network speed is great, my memory is great, my CPU is great, it's storage that's letting me down. What can you do to increase storage performance? Well, there are a number of options here. So the first thing is, we've been talking a lot about storage performance in virtual machines. We've been talking about, hey, we can do, I believe the latest thing we said is 1.6 billion IOPS out of a virtual machine. Honestly, I can't keep track of that. It's a numbers game. But something for you to be aware of is, in order to make that happen, we have made some specific changes in Server 2012 and later around how we scale our I/O infrastructure. So the key point, a couple of key points here, is we have changed it so that we add extra storage channels for separate SCSI controllers, and we have extra channels for number of VPs. So what does this mean to you? Well, if you have a virtualized workload that you're not getting enough storage throughput on, and this wasn't true prior to 2012, but with 2012 R2, you can absolutely get Hyper-V to dedicate more resource to that storage throughput by putting multiple SCSI controllers and multiple VHDs and getting Hyper-V to split up the resource on that. Each of those SCSI controllers gets their own dedicated channel and gets their own resource and bandwidth. The second thing to be aware of is we have now changed our architecture so we scale up the amount of resource we provide for storage throughput with the number of virtual processors in the virtual machine. So if you have a big SQL database and your testing shows that it's bottlenecked on storage throughput, but the CPU isn't an issue, you should consider, hey, maybe I should test that with more virtual processors in the system. Because as you get more virtual processors, we're going to start using that resource for speeding up the I/O. So that's something to be aware of. And we've seen a lot of customers now say, hey, especially with SQL workloads, I see real improvements in I/O as I scale up the virtual machine. Next thing to talk about is, actually, here's a question. How many people are still using VHD? Here, a couple of hands. So everyone else is using VHDX, correct? How many people are using VHDX? That is good. We've done a lot of performance tuning on VHDX compared to VHD. So I've got a couple of graphs here. And there are two things I want to point out with this graph. The first thing that I want to point out, and I always have to nag on this and complain, there is no performance advantage to pass-through disks. Please, 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 please don't use pass-through disks for performance reasons. Makes me really angry when someone tells me that they're using pass-through disks for performance. But something to highlight is, in the old world with VHD, we used to say, well, fixed VHD has the same performance as pass-through. Dynamic indifferencing, there's a performance hit. With VHDX, that's no longer true. The performance you see out of a dynamic VHDX is the same as the performance you see out of a fixed VHDX. That's a big thing to note. So this is another stat worth highlighting, is that in some benchmarks, while we are seeing parity for dynamic disks, we do still see a performance penalty to using differencing disks. So this is really important for you to consider if you're tuning for ultimate performance. Don't be thinking you need to use pass-through. Don't worry about fixed versus dynamic, but do be aware of where you're using virtual machine checkpoints and where you're using differencing disks. They do affect performance. I have a final thing, and this is just another slide saying how much better VHDX performance is than VHD. So next thing to discuss is looking at ODX. So another question, show of hands. I know a number of us are using SANs. How many people here have actually utilized ODX capability in their SANs. A very small number of hands. So, a piece of advice and a word of caution. A piece of advice, if you have a SAN, you should absolutely be looking at taking advantage of ODX. ODX can give you some huge performance improvements on a lot of the day-to-day operations. It offloads the bulk of data transfer from Windows to the SAN, and the SAN can often do it more efficiently. But the words of caution. The first word of caution is that, how many people here, actually, let's have a show of hands. How many people here have ever experienced being burnt by a bad network offload? Come on. We've had this experience. You enable some network offload feature, and that vendor's implementation of that offload doesn't quite work. ODX is storage offload. We are moving capability out of Windows Server into the storage array, and you need to make sure that you trust your SAN vendor, listen to what their statements are about ODX, listen to what their support level is around ODX. I have talked to customers who have had great experiences with ODX. I've talked to customers who've had bad experiences with ODX. And it always comes down to what level of support the SAN vendor has provided for ODX and what level of testing and verification they're doing. So big word of caution there. I would really encourage you to look at ODX, but in the process, be having conversations with your SAN vendor about hey, how much work have you done here? Do you have other customers who are using this successfully? What's your guidance here? Because it is about taking advantage of the hardware capabilities. So I asked before how many had tried ScaleUp file server and how many were using. I know for those of you who are using this, some of this is going to be a recap. I would really encourage people who aren't using ScaleUp file server to take a good look at it for storage performance. A couple of reasons why I highlight this. The first one is Hyper-V using a ScaleUp file server for backend storage is the easiest, most dynamic multipath I/O solution you've ever seen. It's fantastic. For those of us who've configured multipath I/O on SANs and iSCSI, it's a pain, and it's a very static thing. Multipath I/O in SMB, on the other hand, one, you don't have to configure it, it's just there. And two, SMB automatically discovers and utilizes network paths. So it is as simple as, if you're seeing that you're not getting enough throughput to your storage, go and add a few more network cables. And you don't have to reconfigure things. SMB will discover it and take advantage of it. And the performance that we see, especially with virtual machines, when it comes to SMB multi-channel is huge. The next thing, actually, here's a good question. How many people have used RDMA in their environment? A very small number. This stuff, I don't, no kidding, this is black magic as far as I'm concerned. I understand how the architecture works, but the first time I wired this up, the performance difference once you have RDMA in your system is staggering. Now, it is a new technology. It is still relatively expensive. I have yet to hear a customer who's gone yes, we're rolling out RDMA everywhere. However, I've talked to many customers where they've gone, you know what? The performance we're seeing with RDMA is so amazing, we're going to build a dedicated high-performance Hyper-V cluster where we run our performance-critical workloads, and there we're going to use RDMA. Now, for a point of reference, to do an evaluation of RDMA, 2 servers, RDMA NIC, basic infrastructure, last time I priced this, it was about $800 US. To get a basic setup up and running. Well worth doing the analysis of and understanding the performance. It is staggering, and if anyone came to me and said, I am building a high-performance Hyper-V cluster. What do I need? One of the key things I would say is you need to have RDMA networking in there. So now to talk a little bit about storage spaces. Actually, a good question. How many people here are using storage spaces in their environment today? Okay, about 15%. That's about what I expect. We're investing a lot in storage spaces today. One of the big things that we did in 2012 R2 is the creation of the addition of storage space tiering. This is really cool. This is where you can have a small number of SSDs in your storage space, and we're able to take advantage of that to accelerate the overall performance. I actually use this sort of configuration in my lab. One thing I would highlight is, while of course, as a Microsoft person, I would love you to be using storage spaces and tiering to take advantage of that, most SAN vendors are also offering tiering solutions in their infrastructure. It's well worth looking at for virtual machines. You can get a substantial boost in IOPS and throughput without having to go entirely SSD. Because the reality is, if you think about it, if you think about most virtual machines infrastructure, you have a lot of data in virtual hard drives that's only read to or written to occasionally. Where having that on slower storage isn't really an issue. And then you have your critical sections of data. And tiering allows you to optimize that and make sure that you get great performance without having to spend a huge amount on SSD storage. We're also, side note, we're particularly sensitive to this on the Hyper-V team because know how I discussed we can do 1.6 billion IOPS from a virtual machine? The storage rig that we use to test that burns out an enterprise SSD in 60 days. So we're actually quite mindful of how to get efficient usage of our storage. Another thing that a lot of people aren't aware of is the write-back cache functionality in storage spaces. I don't have enough time to go into details on this, so I am just going to say, if you're using storage spaces for Hyper-V, you should definitely be looking at A, the write-back cache, and B, the CSV cache for clustered environments. These are two parameters that can give you sizable performance boosts on storage. So to kind of sum up, what are the recommendations for increasing your storage throughput? First, move away from pass-through disks, please. They don't make sense. And do start considering dynamic VHDX. It has the same performance. Do consider SMB. The ease of multi-channel support in SMB and the infrastructure we have around that. I do want to be clear because I get a lot of people asking me questions about this and being surprised. I have worked with customers who had a traditional SAN infrastructure. They took their existing SAN, they built a 4-node ScaleUp file server on front of that and had their Hyper-V servers talking to that, and they saw performance improvements just because of the more dynamic multipath and because of the caching technologies. So do be considering that. If you're using SMB, look into RDMA. It's huge improvement. If you're still using SANs, be talking to your SAN vendor about ODX. Take strategic advantage of SSD drives, investigate what tiering options are available. A big point, and this is a big debate in the industry, for those of you who follow this closely, there's a debate about the rise of hyper-converged compute and hyper-converged cloud, and this is the idea that do you separate your storage computer network, or do you keep them all on the same thing? Well, the main proponents for hyper-converged cloud architectures argue that it's flexible, it's scalable, it's easier to deploy and manage, and all these things are to some extent true. It is not the highest performance way to go. If you are designing for performance, separate your storage and compute. And one of the key reasons why I mention that is if you look at a ScaleUp file server, what we're actually able to do is we're able to take all the processing power and all the memory on the ScaleUp file server nodes and dedicate that to optimizing storage performance. When you're running with converged storage, so if you're using a SAN and you have CSV and you're running Hyper-V directly on it, we have contention between the storage stack and the virtual machines about where the memory goes and who gets the CPU. And the way we've designed the system, the virtual machines always win. So we will make sure that the virtual machines win and the storage stack gets what's left over. So if you're designing for peak storage performance, decouple storage and compute. So now controlling storage performance. As I mentioned, a lot of people aren't used to thinking about IOPS and throughput. So we've been putting a lot in the platform for this. We've been putting in counters into Hyper-V, into System Center that allow you to measure IOPS, allow you to track IOPS. The key thing that we've tended to build around is this concept of normalized IOPS. And we tend to use normalized to 8K. So when you see Hyper-V or System Center talking about IOPS generically, what we're actually talking about is normalized to 8K. A key point to make here is that's a lousy metric for understanding your performance. So when you're in the measuring performance view, don't use this control. Look at the throughput, look at the application performance. This has been designed to provide an easy way to control and account. It's not designed for measuring. So in Windows Server 2012 R2 specifically, we've provided some controls for storage costs in Hyper-V. So the first one is we allow you to limit storage costs. So you can go in on a per virtual hard drive basis and say, this virtual hard drive, no more than this amount. Now, two things to consider with that control. One, it's very effective. It's a great thing if you have a non-critical workload that you want to control and not have it monopolize resource. But there's actually a second story here that I really love, and I would encourage people to think about it. And it's a story about the importance of consistent and predictable performance as opposed to just always going for peak performance. So the first story I have, and this one I've had multiple times, I talked to someone who's working on a VDI deployment. And they've sat down, they've done their numbers, they've figured out, okay, I want to have 300 users in this VDI deployment. Their current desktop performance is about 100 IOPS. I'm going to count on them not all going hot at the same time. So I'm going to make sure I have a storage array that can deliver 20,000 IOPS fairly reliably, and that should be good. And that all looks good on paper. And they deploy this, and for the first couple of weeks, things are okay. But after about 3 or 4 weeks, they start to get end users complaining about performance. Now, an aside on this, let me tell you, the #1 killer of VDI projects is users complaining about the experience and performance. In order to be successful with VDI, you need to make sure your users believe that this is a good thing for them. But why are these people complaining? They weren't complaining at the start. The performance is equitable to what they had. Well, what's happened is, and it's a really short time, in the space of 3 or 4 weeks, those users have realized, almost subconsciously, you know what? If I get on my system at 8 a.m. or 6 p.m., wow! The performance is amazing! Because no one else is on, and when they do something, now they're getting 5,000 IOPS. But man, if I'm on there at 9:30 in the morning, Now, what they're getting at 9:30 in the morning is exactly what they got on their desktop computer, but they've forgotten that. You know, they've seen the glory. They're like, wow, like this could be awesome. And all of a sudden, they're complaining to you because their performance isn't always awesome. So a strange thing to consider, and I've seen people do this and it be successful, is I've seen people go, fine, we're going to do a VDI, we're going to size it, but each of those VMs is capped to 100 IOPS. And if you get on at 6 p.m., I don't care that there's spare resource around. You're getting 100 IOPS. And the funny thing is, the result is happier users because they get the same performance predictably and consistently. The second story that I have here, this one I love. This one just makes me laugh every time I think about it. I was working with a company. They had a large private cloud deployment. They had their infrastructure carved up by performance bands, and they had a big project to go through and replace their storage for their highest end performance cluster with a goal to double the performance. Sounds good. And we helped them through this process, and it was a success. It was done with zero downtime, no effect to workloads. And a week later, one of the workloads that they had on their high-performance cluster was their SAP infrastructure. And a week later, they had a red ticket from their accounting department going, crap, something's wrong with the SAP server. And they had a big panic. And what had happened was the head of HR and accounting for this company ran the paycheck twice a month, and she knew that if she came in the morning, got the data in the system by 10 a.m., hit the big go button, that everything would be done by 4:30 in the afternoon, and she could go home happy. Now, on this day, she'd come in, she'd got the data in the system, she'd hit the big go button, and she'd gone out, and at 1 p.m. in the afternoon, she'd got the I'm done message. And her first reaction was to go, oh crap, something's gone wrong, it hasn't processed half the payroll. Now, we laugh at that, but that's actually like a reasonable human expectation. So it's really important to think about, when do we want to do peak performance versus when do we want to do consistent performance? So the second thing that we have the controls. The second thing we have is we have the ability to do alarms on limits. So we allow you to specify a minimum IOPS, but that isn't enforced. Instead, that's something where you can say, if this virtual machine ever goes below this amount of IOPS, let me know. I've actually got a link to a blog post by one of our MVPs where he went into great details on how to access that counter and set up alerts and integrate that into the system. The final thing I have to say on storage controls is we have a lot more here coming in the next release of Windows Server. And we've been discussing some of this already, but we're going to be doing a lot more work integrating with ScaleUp file server to provide file server side QoS controls to give you finer grained controls over large sets of virtual machines. So, I'm running tight on time. Have to speed up. Networking. So networking is the second thing we hear about after storage. Now, the first thing that I will say about networking, and I will challenge all of you on this, is I would argue that most of you are not paying enough attention to network performance. The number of customers that I have talked to and said, what are you doing about network performance? And their answer has basically been, we've given up on network performance. We will never have enough networking. It will always be a problem. Don't do that. Understand your network. Understand what you need. Do what you can to get the most out of it and get the control out of it. And this is, by the way, networking is a great area where people just don't get the throughput that they're paying for. So, increasing network performance. I'm going to have to talk at a high level. VMQ, RSS, VRSS. these are a bunch of phrases and jargon that network people love to throw around. And it's actually really interesting. First show of hands. How many people have heard these phrases before? That's good. Just wanted to check that. So when we first started talking about this, I got really confused because at a 20,000 foot view, VMQ, RSS, and VRSS all kind of sound like the same thing. Because what they're at a 20,000 foot view, they're all about how do we take a network connection and spread the processing for that network connection across multiple processors. So I was actually surprised. I was talking to some of the network gurus on the team, and I made this observation. I'm like, this all kind of looks and feels the same. And they laughed at me, and they said, that's because it is the same. So an interesting detail that a lot of people miss here is in the hardware, there is one set of network queues. And it's the same hardware that's used for VMQ, RSS, and VRSS. These are all just different software implementations of ways to use those queues. So RSS is how we can use those queues in a physical computer in the host. VMQ is how we can use those queues in the virtual switch and in the virtual network infrastructure. And VRSS is how we can use those queues inside of a virtual machine. So, some key points to make here on this topic. The first one is, and a lot of people miss this, if you have a 10 gigabit connection and you don't use these technologies, you will only get about 3 gigabit. Full stop. Today, where we're at with processor technology, it takes an entire core to push about 3 gigabit of network traffic. So if you're not going to invest in making these technologies work and get them working in your environment, and it's amazing. I've talked to people where it's like, we have 4 10 gigabit adapters, but we haven't enabled VMQ. Well, that's a waste. You have to make these technologies work. Now, at the same time, in full transparency, I'm well aware these are the leading cause of support calls we have today. And it's new technology, it's a network offload, and this is somewhere where you're going to have to work with your hardware vendor in order to make it work. But it's worth it. And the reality is, if you cannot get networking hardware that does VMQ reliably, does RSS reliably, you're just not going to get the performance you need out of your network infrastructure. I'm sorry to say that, but it's a reality. These technologies are key to getting over 3 gigabit. So, and we're working with the hardware vendors and so on, and I know many people have been going through that process. Do be aware we have lots of customers who have got this working, and we're happy to engage with hardware vendors and make sure we get the right drivers and so on for the solution. Next thing to be aware of is large send offload. This one is actually a very simple, no-brainer technology. This just reduces the amount of CPU we spend for sending traffic. It is enabled by default in most adapters. It's well worth checking to make sure it's enabled in your environment. This tends to cause about a 20% reduction in the amount of CPU we use in order to send traffic. The next one, and this is actually worthwhile discussing, is jumbo frames. Another show of hands. How many people have jumbo frames working in their environment? That's not enough. So, a couple of things to understand about jumbo frames. First reason, why should you be using it? It drastically reduces the amount of CPU that we spend sending network traffic. Why aren't you using it? Well, jumbo frames don't actually work in the real world, per se. The problem with jumbo frames is jumbo frames work until you hit the first piece of networking gear that doesn't support jumbo frames. Now, for most of us, that first piece of networking gear is the first piece of networking gear outside of our control that connects us to the internet. So the key point here is, now, realistically, you can't use jumbo frames for your external connectivity, but you absolutely can use jumbo frames for the traffic flowing between your storage and compute nodes, and for the traffic going between your compute nodes. So it's not that hard to set up. It's well worth the investment for your internal network traffic. So a little note here. The number of customers I've run into where jumbo frames just work in their environment and they've never turned it on is staggering. So a simple test to see if jumbo frames just work in your environment is this command down here, ping-l 1904. You can do that in your environment, and if ping works, and guess what? You can turn jumbo frames on, and it's going to work. If it doesn't work, then you have some piece of networking infrastructure that doesn't support jumbo frames. The final thing to talk about for optimizing network performance is our support for SRIOV. And SRIOV is a network virtualization technology that allows us to essentially connect a virtual machine directly to the underlying network adapter. And this is both good and bad. The good of it is you can't beat this for throughput and latency. You just can't. When we see customers doing this, they get within 1 or 2 percentage points of what they see on physical hardware without virtualization in there. The bad is you've bypassed the entire networking stack in the parent partition, and we have a lot of partners, and we ourselves are putting a lot of value in there. So there's a lot of virtual switch extensions, there's a lot of partner integration that all goes away if you're doing this. The support that we did in Windows Server for network teaming in the box, well, you can't take advantage of that if you're doing this. So much like RDMA, SRIOV is a technology that I see people using in high-performance clusters. If you build a Hyper-V cluster, which you're like, this is going to be my top-tier performance workloads, looking at SRIOV is a good idea. So, controlling network performance. We've been doing a lot of investments in quality of service. We also have partners who've been doing a lot of investments in quality of service. There are software options. There are hardware options. There are software options from Microsoft. There are software options from third parties. There are hardware options from third parties. It's really hard to step through and give the definitive guidance here. However, there are some high-level things I would say. The biggest, most important one is do not mix and match quality of service approaches when it comes to networking. That will always end in tears. So it's something that you need to do at the beginning is you need to look at what do I want to control, what level do I want to control it at, and what makes sense. So do not mix software and hardware, quality of service, bad idea. Even inside software quality of service, we provide different ways to do it. You can do it per port, you can do it per virtual network adapter. Don't mix those two. Decide that you're going with one approach and use the approach that works for you. The next thing to be aware of is be aware of what your requirements are and what you're really aiming for. So with the Windows quality of service and with a number of the third-party quality of service offerings, you have the option of going with a relative mode or a bandwidth-based mode. You can either say, okay, I'm going to assign weights to different classes of networking, or I'm going to set hard limits. Now, weights are great because they're flexible. And if I increase my bandwidth or I decrease my bandwidth, it all just magically works. However, you cannot write a customer SLA around weights. I don't think anyone here would sign up for a service from a hoster where the hoster says, I guarantee that you will get 20% of whatever network capacity I have available at any point in time. That's not viable. So be aware of your environment. If you're running an internal high-performance cluster, yeah, weights are probably the best approach to go for. If you're providing a service to external customers where they're expecting guarantees, then you want to go with static QoS, with absolute bandwidth QoS. So I have 5 minutes to try and get through memory and CPU, which is actually, I'll be honest, kind of how I planned it, because I do want to be clear, memory and CPU are not just third and fourth, they are far third and fourth. Most people, when they look at performance in their environment, storage and networking are the big ones. So let's talk about memory. Increasing memory performance. Let me highlight, I would posit that most of you have never sat down and thought, how do I increase the memory performance in my environment? It's not something that most people think about. But there are actually some things that you can do here that have a drastic effect on the performance of your workload. So, as I'm short on time, I'm hoping most people are familiar with NUMA architecture. This is becoming more and more prevalent. These days, if you have a server that's multiprocessor, it's actually NUMA. It used to be that NUMA was fairly rare. These days, it's quite common. One of the interesting aspects of NUMA systems is that what happens is you get memory banks assigned to individual physical processors. And if a process is running on one processor and accessing memory assigned to another processor, you actually see a performance hit. And NUMA provides a way to inform applications, hey, this memory is associated with this processor. What we've done is in 2012 R2, we've introduced the concept of guest NUMA. And this is where if we have a virtual machine where it's using resources from multiple physical NUMA nodes, we expose that information into the virtual machine so that high-performance applications like Exchange and SQL can be aware of that and change the way they use memory. So, what can you do here? Well, the first thing you can do is you can disable NUMA spanning on the Hyper-V host. This is actually an option in the Hyper-V host settings. By default, this is turned on. And by default, what we will do is when you start a virtual machine, we will, to our best effort, try and put all of its memory in a single NUMA node, and we will try and schedule its virtual processes on the NUMA node that has that memory. But if we can't make that fit, then we spread it across NUMA nodes. And depending on your system and depending on your workload, we've seen that spread behavior cause up to a 30% performance hit. Some systems it's only 10%, sometimes it's more, sometimes it's less, but 30% to 10% is reasonable. And by the way, if you are curious if this is happening in your environment, you can actually go and check the Hyper-V event log. We file a warning in the event log whenever we had to span NUMA nodes in order to start a system. So, if performance is your top thing, you can disable NUMA spanning. And what this means is it means we guarantee that virtual machines will always be contained inside a NUMA node and you'll get the best performance. However, it does mean you're not going to be able to get as many virtual machines on the server. Once you disable NUMA spanning, those last couple of virtual machines that would have started will now fail. The second thing to consider is to enable virtual NUMA on large virtual machines. We don't do this by default. You can go into a virtual machine and enable it. I will highlight it's mandatory to do this if you disable NUMA spanning. Because if you disable NUMA spanning and create a virtual machine that's larger than a single NUMA node, we just won't start it. So that's how you increase memory performance. What about controlling memory performance? Well, if you're using dynamic memory, there are a lot of options here. You can set your minimum, your maximum, the memory buffer, the memory priority. Side note, not enough people take advantage of memory priority. If you're using dynamic memory and running different priority workloads, configure the memory priority for it. We have a lot of host counters available for this, and you can go really deep on understanding what's happening and controlling it. If you're using static memory, today, not much you can do, in controlling. You can set the memory, and that's it. In Windows 10, next release of Windows Server, we're adding the ability to do online resize of memory. But what I think is actually a lot more useful is we're exposing what we believe the memory demand is inside the virtual machine. So next release of Windows Server, it's going to be much easier to go in and understand what's happening and control the memory usage. The final thing that I'll talk about, and we hate talking about this, is we do have a tunable memory reserve. And what this is when you're running Hyper-V, we dynamically try and figure out how much memory the parent partition needs, and we reserve it. Now, you can go in and tune this by hand. And you can tune this by hand to allow you to run more virtual machines. You can tune this by hand to give more memory to the host to get better performance out of host components. Let's say you're doing converged compute and storage and you want more memory to be available for storage. You can go in and you can set this value high. The reason why I say use with caution is if you set this value too low, we will bug check the box. Hyper-V is well ingrained into Windows Memory Manager. And if you tell us we can take all the memory,
Units?
What?
What are the units?
The units is megabytes. If you do a search for that key, you will actually find a KB article we've done on it. But if you set this too low, we will actually take so much memory from the parent partition that it can't do the basic functions it needs to do. So as a rule of thumb, I would never set this below a gigabyte. There are some systems, some hardware where it needs to be higher than that. So do be careful if you're going to play with that. Use it with caution. So the final thing I have to talk about is CPU. And the first thing I want to address here is I get a lot of people asking, hey, Ben, what's the supported VP to LP ratio for CPU? And we don't do that anymore. That is actually an example of a micro benchmark. And the story here is we released the first version of Hyper-V and we said we support 4 VPs per LP because that's what we tested. And then we released the second version of Hyper-V and we said, great, we support 8 VPs per LP because that's what we'd tested. And after that, we had hardware partners coming to us and saying, but we've tested a VDI workload at 12 LP to VP, and we want to do that. And we're like, great, if it works. And they're like, but we can't do that because you say it's not supported. And so then we had this goofy period where we're like, well, we support 12 VP to LP if you're doing VDI, but if you're doing server, do 8 to 1. And then we had people going like, but I tried 16 to 1 and it worked great. And then we had people going like, but I'm running 12 to 1 on SQL and it works fine. And we ended up going like, you know what? The supported ratio is the one that works for you. And if you want to know if you're running too many VPs per LP, are you getting poor performance from your workload? Maybe you're running too many VPs per LPs. It's a micro benchmark. It's not what you should be measuring. You should be measuring the performance of your workload. So there are actually some things you can do to increase CPU performance that not everyone's aware of. Here's a simple one. Enable the high performance power plan in the host. Not a lot of people realize this. It has a big impact on Hyper-V performance. This is a common mistake that I see people make. They're running on hardware that does aggressive power saving by default, and it impacts Hyper-V performance. Very simple change, drastically increases performance. Also increases the amount of power you use, unsurprisingly. But once again, if you're building for performance, very simple thing to do. Another one, don't enable our CPU compatibility mode. We have a feature in Hyper-V where if you have a cluster that's got different version processors, you can enable CPU compatibility mode, and live migration magically works. And isn't that great? Let me be crystal clear. You enable CPU compatibility mode, all your virtual machines are now Pentium 4s. We just took away every CPU instruction that Intel has released in the last decade. That does affect performance. Intel did some great work with AES offloads in the CPU for encryption. You don't have it if you turn this on. You do if you don't. So if you care about performance, build your infrastructure so that you have matching processors and you don't have to turn this on. So controlling CPU performance. This is very simple. Hyper-V actually provides great controls. They're in the platform. We have the reserve, the limit, the relative weight. Most people I see only take advantage of the reserve, but it's a great feature. If you have workloads that you care about, you can go in and say, reserve 25% always available for this. And when there's contention, we will make sure that that virtual machine gets what it needs. So I am 7 minutes over. I'm going to open up for questions quickly, and hopefully people won't be too mad at me. So any questions about performance in Hyper-V? Someone? Anyone? Apparently my speech was so good that everyone's like, no, I know exactly what I need to do.
I was wondering a little bit about the CPU backwards compatibility.
Yep.
In VMware, you have the option to set exactly the family of processors you want to utilize. That is not possible in Hyper-V.
This is actually, so the question was basically, hey, VMware gives finer grained controls over CPU compatibility. Why doesn't Hyper-V do that? And there are kind of two reasons why. The first reason why we historically haven't done that is we wanted to make sure that we covered people who had CPU compatibility with the server that they hadn't yet bought. And that's one of the big challenges with getting into the fine-grained control there is, if it's compatibility with a server that you're going to buy in 6 months' time, that gets really hard to predict and so on. And people have enjoyed the simplicity of the interface. It actually came up again recently where we were discussing like, hey, should we revisit this and change this? And we probably will be changing it in the future, but I'm fairly confident that we're not going to be adopting the VMware model, because you may have heard this in passing, but at Microsoft we're a bit focused on hybrid cloud right now. And one of the challenges we have in regards to CPU compatibility is, and honestly I don't know what the answer is here, we're still working on this, is I need to figure out a way where you can say make the CPU of this virtual machine compatible with hardware in Azure that I don't know about. And that's really the challenge that we have to face. Is something we want to do better on, but the answer's not entirely obvious. So since I've gone over, I will wrap up. Thank you very much. Please don't let Mark put a red tag in the bowl.
Red tags. Remember, red means he's red hot, and he is.
No.
There, you know?
No, don't listen to this man. So thank you very much.